Okay, everybody, this is chapter 10, section 4. These are dealing with radicals again. This is solving radicals. This is a section that we have to take our answers and plug it back in to make sure it works. There are times where we get an answer, but it won't work. And so that's part of doing the problem. So let's make sure that we're understanding I have to take it and plug it back in, because sometimes I'll have no solution. Okay. So big section 2 for stuff that you're going to use later on, especially in Algebra 2. You're really going to have to make sure that you do a good job here. So when you get into Algebra 2, you kind of remember it, and it doesn't take you so long to get it back. Okay. Got a couple definitions up at the top. We have radical equations. So it's an equation with a variable under a radical. So we're typically going to be working with x being underneath the radical, and we got to get it out of there. Okay. An extraneous solution is an answer that doesn't satisfy the original equation. So we have to plug answers back in just to see if it makes the equation true. Okay. Just to give you a little heads up too, we're going to have to x factor a little bit in this one. And once again, like I said, we have to plug stuff back in. Okay. I'm also going to be writing some extra notes. The notes here are not really very detailed, so I'm going to write extra notes. So give yourself a little bit of room on this, and some of these problems might take a little bit of room to solve. Okay, so just use the page as much as you can. Okay. First thing we're going to do in problem number 1 is solving by isolating the radical. Isolate means get it by itself. So we need to isolate the variable first. Okay. So in this case, for this question, I'm going to have to subtract 7 from both sides. I'm going to get the square root of 7, or I'm sorry, square root of x. It equals 9. Okay. And then we have a second step. I need to get rid of the radical. So in this case, to get rid of the radical, I want to square both sides of the equal sign. Okay. So what I'm going to do is I'm going to go down, and you don't have to keep writing all this out. Okay, you can do a lot of this in your head, but I'm going to show you all the steps so that you have something to kind of refer back to. I'm going to square both sides, and I think if you guys remember from chapter 9, there's a little 2 right here. Okay, and they cancel each other out when I do that, so that leaves me with what's ever underneath the radical sign, but it squares the other side, so I get that. Okay. So x equals 81, but does it work? So I have to go back to where I started. X is now 81, so I'm coming from there to there. Plus 7 equals 16. Okay, and if you remember your perfect squares, 81 is perfect. The square root of 81 is 9. 9 plus 7, does that equal 16? Yes, it does. So we checked it, it's good. Okay, so that's trying to isolate a variable and then get rid of the radical. Okay, so once you give this one on the other side over here, once you give this one a shot, once you hit pause and go ahead and try to solve that one. So first thing I'm going to do is add 5 to both sides to isolate the radical. It gives me this. Okay, I want to get rid of the radical, so I'm going to go ahead and square both sides. That leaves me with x equals 9. I want to go back to where we started, okay, and put in 9 for x. Square root of 9 is 3 minus 5, and does that get me -2? And it does, so that solution works. Okay, so pretty easy there, I hope. We just, to get rid of the radical sign, you square both sides, and you don't have to write this step all the time, especially when you get good at this and you know what you're doing. Just making sure we understand what the step is and what it does for our problem. Okay. This problem, it's kind of a cool problem. It's a physics problem. Some of you guys, if you take physics down the road, you do this. I'm just going to write it out and do it for you. The math is not that difficult, but it looks scary. Okay, so first off, a pendulum on a grandfather clock, it swings back and forth, and there's a relationship between how long it takes it to swing back and forth and how long the arm of the pendulum is. Okay, so they measure that in time. It takes 3 seconds for it to do a complete swing. Okay, so I'm going to take that 3 and put it in for time. Gives me this. Okay, and following the same rules we just did, I'm going to go ahead and isolate the L. Well, first thing I got to do is divide both sides by this 2. So I'm going to get 3 over 2 equals square root L over 3.3. Okay, I want to get rid of the radical, so I'm going to go ahead and square both sides. So once again, that's a step that you can do in your head, but you want to really probably do it for this one. I'm going to get 9 over 4 here. The radical goes away over here. Okay, so there's two ways I could do this problem at this point. What I'm going to do is just cross multiply. Okay, I'm going to go L times 4 is 4L, and then I'm going to go here. You get 9 times 3.3 is 29.7. Okay, and then I'm going to just solve it for L by dividing by 4. Okay, and I get L is equal about 7.4. I think there's some rounding going on there. Okay, so a really ugly looking problem. We get scared of it, but if you know steps and rules, you follow the steps and rules because they're not going to change. Okay, so on this one gets a little bit different because you get a decimal answer that's really kind of small. Once again, I'm going to take the 1 second and put it in for time. So 1 equals 2 square root L over 3.3. I'm going to divide both sides by 2 again, isolate the variable. Okay, got to get rid of the radical, so I'm going to square both sides. And I get that. And I'm going to go ahead and cross multiply again. I could have got rid of the fraction right here by multiplying both sides by 3.3. This does the same thing. And I think you guys have seen this before. We've done proportions before. So we'll stick with that. And because we're going to divide a smaller number by a bigger number, I get a decimal, and I believe it comes out to be about 0.82, maybe 0.83, which is about 9 inches. Okay, so really, it's a tough problem, and I just did it for you, but we did the same steps we did for the other problems we just did. Just showing you how you apply that kind of concept. Okay. All right. So here we get into some radicals on both sides of the equation. I don't want the radical signs there, so we're going to use a step from the last couple problems we do. I got to get rid of the radicals. So what I'm going to do is, let's write this down too. Get rid of the radical on both sides first. Okay, so square both sides. Okay, so I'm just going to take both sides, and this is another thing that I could do in my head. Okay, Okay, I don't have to write it out like I'm doing here for you, but I just want to make sure you understand what we're doing, have a good good example of what to do. I'm going to square both sides. Okay, so what all that does is just gets rid of the radical and leaves me with what's inside. Okay, and now I'm just solving this equation. So this is back in August doing stuff like this. I'm going to get rid of the x from both sides. It's the smallest one. I get this. I'm going to go ahead and add 11 to both sides. And that's going to get me 4x equals 16 and divide it by 4. And x equals 4. Okay. But I want to make sure this works. So I'm going to take this 4 and go plug it back into both the x for x in the original equations. So I'm replacing x with 4. I'm going to get, in here, I'm going to get 20 minus 11 gives me square root of 9. 4 plus 5 gives me square root of 9. And we all know that equals 3, but does the square root of 9 equal the square root of 9? And it does. So that solution worked for us, okay? All right, so just, you know, this right here, if I got radicals on both sides and they're isolated, you know, in my head, I'm going to square both sides just to get rid of the radical sign. You don't need to write that out. They go away. Solve it. Check it. Okay? So hit pause and try this next one on your own. But make sure you plug it back in to see if it works. Okay, so I square both sides, got that, and solve for x. I'm going to get rid of the 5x first on both sides. I'm going to get 2x minus 4 equals 10. I'm going to go ahead and then add 4 to both sides. So I get 2x equals 14. I'm going to go ahead and divide both sides by 2. And x equals 7. Okay. I'm going to go back and plug it back in though and see if it works. So 7 times x is now 7 minus 4 equals 5 times 7 minus 10 plus 10, sorry. So I get square root. 7 times 7 is 49. 49 minus 4 gives me 45. 5 times 7 gives me 35. 35 plus 10 also gives me 45. So, you know, that square root of that's going to be somewhere about 6.8. But square root of 45 equals square root of 45. That is true. So that worked. Okay, so here we might do a little bit of factoring, but this is really where we got to check our answers and see if it works. And there's a little issue that kind of comes up here that I'll talk about. Okay, so the first thing I want to do is radicals are isolated here, but then I want to get rid of them. So that forces me then to have to square both sides. Okay, so same rule that we've kind of used so far in this section. All right, I get x squared equals x plus 12, okay? So I isolated first, and I really didn't have to do anything, it was already isolated. Get rid of the radical. Now solve. Well, to solve this, I need to get everything to the same side of the the equal sign. So it's back to when we were factoring stuff. I'm going to subtract the x and the 12 to get everything over here. Okay, well, that looks like now that I should probably go x factor this. So we use the big X here. Remember, there's a 1 right here, so 1 times the negative 12 on top. Middle value, so that's a 1 right there, negative 1 on the bottom. If the top's negative, then these need to be different signs on the sides. And I believe that it's going to be 4 and 3 multiply up and add up to negative 12 and negative 1. Okay. Now remember, because it equals 0, I have to solve it. Remember, if I'm doing this one, all I need to do here now is change the signs of the numbers on the side. And that's because that leading coefficient was a 1. So I'm going to get x is equal to 3 and x is equal, I'm sorry, negative 3, and x is equal to positive 4. Okay. But I got to go plug it in and see if it works. So I'm going to go back to the original problem and plug each one in to see if they work. So I'll do that over here, and then I'm going to have to erase it. Okay, so I'm going to start with the negative 3 first. Negative 3, which is x. Remember, I'm back at the original problem. Square root negative 3 plus 12. So negative 3 equals square root, and negative 3 plus 12 is 9. Take the square root of 9, and I get 3. Now, if you guys remember back in chapter 9, when we took the square root, it was really a positive negative number. Well, that technically shouldn't that work? And it doesn't. Okay, because I can't take the square root of a number and get just a negative number. All right, so that's an extraneous solution. It doesn't work. Okay, but I'm not done because I had 2 answers. So I'm going to erase this over here and plug in 4. Okay, so I got x is now 4. So square root 4 plus 12. Remember, you're plugging 4 in for both x's in the problem. 4 equals the square root of 16. So 4 equals 4. So that works. It's a solution, and it's not going to be extraneous. Okay. So that's how you do that particular one. I'm going to erase this, and so I can do this other problem. Okay. All right. So we got to go back to the first couple of problems we did in this section. I got to isolate the radical first. So I'm going to get rid of this 8. And get the square root of 3x equals negative 6. I'm going to square both sides to get rid of the radical. Okay, so that gets me this. Remember, when you square a negative number, it ends up being positive. So I get positive 36. I'm going to divide both sides by 3 now. And I get x is equal to 12. Okay, so here I didn't have to factor it, and I only get one answer, so my checking's not going to be that tough. But I need to go back to the original problem and plug it back in. So square root 3 times, now x is 12 plus 8 equals 2. Okay. So square root 36 plus 8 equals 2. The square root of 36 is 6 plus 8 equals 2. So 14 equals 2. Well, that's not true. So there is no solution. That's an extraneous. 12 is extraneous. So there's no solution. Okay. All right, so it's a little bit using a bunch of the different rules we had and plugging it all into one big problem. Okay, so why don't you guys hit pause? and try these, and then you know, you got to plug whatever answers you get, you got to plug it back in to see if it works. Okay. Okay, I need to isolate, in this first one, I need to isolate the variable. So I'm going to get rid of the x, or the 6, I'm sorry, by subtracting 6. That negative sign stays there, and I get 4, okay? What I'm going to do is to get rid of that minus sign, I'm going to divide this by -1 first, okay? So I get that, 2x equals now -4, okay? Now I want to get rid of the radical sign, so I'm going to square both sides. That gets the radical sign gone over here, and over here it gets me positive 16. Okay. So I'm going to divide both sides by 2 now, and I get x is equal to 8. All right. So hopefully a pretty easy problem there. But I need to see if it works. So I'm going to go ahead and plug it back in. The x is now 8 equals 10. So 6 minus 2 times 8 is 16 equals 10. The square root of 16 is 4. Two equals 10. That's not true. So there is no solution to that. Okay, it's extraneous. So get to know the word extraneous. That kind of comes back up a lot. Okay. All right. What I'm going to do here, the radical's isolated, so that's good. I'm going to go ahead and square both sides to get rid of the radical. This gets me a positive y squared over here, and I get y plus 6 over here. Well, now I need to get, in this case, I have to get everything over to the same side. So I'm going to subtract the y and the 6 over. Okay, so that tells me, hey, I got to factor this. Okay, so draw your x. There's a 1 right here. Times it to the -6 on top. Remember, that's a -1 right here too. So -1 on the bottom. If the sign's negative on top, then these have to be different. So I'm going to get a -3 and a +2. Multiplies and adds up. Okay. And I want to solve it so I can use that. I just changed the signs because the leading coefficient was a 1. So I'm going to get -2 x equals -2 x equals +3. Well, now that's going to make me then have to go and check both of these and see if it works. Okay. Or I'm sorry, this is y. My fault. Okay. All right. So I'm going to go plug that in. Now it's -y, and I got I'm going to use -2 first. So minus -2 equals square root -2 plus 6. So really, remember, that's going to change the signs. I get 2, and then the square root -2 plus 6 gets me 4, and the square root of 4 is 2. So, hey, that one works. Okay. All right, so now I'm going to take the 3 and plug that in. So remember, y was negative, but I'm putting a +3 in. And then y is 3 again, plus 6. So I get -3 equals the square root of 9, which is, you know, technically it is plus or minus 3. We'll just say it's 3 because it has to be both. So that one's not going to work. So +3 was an extraneous solution. It didn't work. Okay. All right, so your section summary, we want to make sure that we isolate the radical first. We want to square both sides to get rid of the radical. We want to solve for the variable, and then we need to check our answers. You have to check your answers. That's the only way to know if it works or not. Just because I get solutions doesn't mean they're going to work in this point, okay? So hopefully you did a good job there. I know that took a while. Practiced a lot on that homework, and see how well you do, okay?